Hello everyone, I Nikhil welcome you to Vigyan Bharat. In this video, I'm going to discuss problem number 4 from TIFR GS 2021 Mathematics Entrance Examination. Before moving ahead to the solution of this problem, just important information. If you are new to our channel, then do join our Telegram group. It will be very helpful for you if you are preparing for these computer examinations. So you can find its link in the description of this video as well as the about section of our channel. So let's move ahead directly into the lecture. What we are given a set S, which is the collection of all those x in R such that x is they are positive and they satisfy this equation. So we are looking for all those values of x which satisfy this equation, and of course they are positive. So this is an MCQ type problem. So you have to answer whether how many solutions to this equation are possible. That is, this set S is empty. If it's empty, it means that S does not contain any value in R plus. If it's non-empty but finite, or if it's countably infinite, or finally it's uncountable. So we have to choose among these four options. So let's move ahead now to the solution of this problem, how we can approach this. I have solved this problem in two ways. You may solve it in even more, but first let's see a simpler approach. Consider this equation 1 plus x squared times tan 2x equals to x. In our first approach, what I'm trying to consider, I'm trying to looking for the solutions of this equation, which is also same as finding the zeros of this function. If I take this x on the left, then this will become 0. That is, if you take this x on the left, then it will become 1 plus x squared times tan 2x minus x equals to 0. So it is equivalent to find those x which satisfy this. So I'm writing this fx equals to this one. Since if you remember, I'm looking for only the positive real values in S. S consists only of those x which are positive. So that's why I have here written that I'm looking for those x in R plus where my fx is 0. Now here to find those values of x directly, one simplest way, of course, if you know graphs, if you are familiar with the graph of tan 2x, then it will be quite easy for you. First, I have plotted this graph of tan 2x. If you see, between this interval, there is some finite interval in which this function takes values from minus infinity till infinity, and it repeats its behavior over all the real over the set of real numbers. Just a small hint, you know that tan x is periodic between minus pi by 2 to pi by 2. This function is periodic between minus pi by 2 to pi by 2. So you can, it's a question to you to find the period of tan 2x, and you can find the interval easily here. So the point is that it repeats its value and it assumes all values between minus infinity to plus infinity. Similarly, if you plot this function x upon 1 plus x square, then you are going to see at 0 it assumes a value of 0 here, and after 0 this quantity is positive, and before 0 this is negative because of the numerator. X upon 1 plus x square, this will be x upon 1 plus x square will be negative for x less than 0. That is, x belongs to minus infinity comma 0. If you see now again both these two graphs, if I sketch the graph of x upon 1 plus x square onto the graph of tan 2x, you can easily see like it's a rough sketch, although very useful. This is a small observation that the graph of 1 plus x square, as x approaches infinity, it converges to 0. It's trying to go as close to 0 in the right as well as in the left. So in between, if you see, there will be infinitely intersections between the graph of tan 2x and the graph of x upon 1 plus x square over all of even r plus, if you see only in the right side, because I am looking for the positive values. So in this way, it's clearly visible that from here that this will going to have countably infinite number of zeros. Okay. Now let's move ahead to the second approach, which is a very elementary approach, which we have learned from our intermediate classes when we started learning trigonometry. So I'm now rewriting the value of tan 2x. What was given to us? We were given 1 plus x square times tan 2x equals to x. This was given to us. So I have now find the value of tan 2x simply by taking the factor 1 plus x square on the right. We know that in a right triangle, tan theta is given by perpendicular upon base. So now for any x positive, from here I am comparing this. X is my perpendicular and 1 plus x square will be my base for this right triangle. Now for any x positive, certainly 1 plus x square will always be greater than 1 for any x positive, because you are adding something to 1, so it will be greater than 1. Okay. And from here, because x is positive, so I can divide by x. I can divide by x. Okay, try to see here. Try to observe this. This is, I hope this thing is clear to you. The starting part, this one. After that, what I am writing, this and the values of x I am choosing. Suppose say between 0 and 1. So my x is less than 1. So in this case, my x is this and this is greater than 0. This is how I have written here, this thing. So if you consider only this part, I can divide by x, and if I divide by x on all the sides, it will be like this till here. And if you compare this with this one, then 1 plus x square by x is greater than 1. Since x is positive, we can do that easily. There is no harm in doing so. If you take the reciprocal of this thing, 1 plus x upon 1 plus x square, it will be strictly less than 1. Since this quantity is greater than 1, so its reciprocal will be less than 1. And of course, this is greater than or equal to 0 always, because I am assuming my x to be positive. Can be at max 0 if it is 0. Now the interesting thing is, this quantity always lies between 0 and 1. So this is the value of your tan 2x. Now see, this is the value of this tan 2x and this thing. Now what we are saying, this quantity lies between 0 to 1 from here. What I am saying, for all my x positive. So what I am trying to say, instead of this, can I say, now I am asking an equivalent way, for what values of positive values of x, for how many values of x my tan 2x will going to lie between 0 and 1. From the graph of tan x, I know in the interval minus pi by 2 to pi by 2, it assumes the values between minus infinity to infinity. So certainly in every interval where it will repeat its value, even tan 2x will going to assume values between 0 and 1 countably infinite many times. That is visible from its graph here. If you restrict from 0 to 1 this portion on the y-axis, then if you cut this thing, these values are assumed by countably infinite values of the domain, what I have written here. So tan 2x is going to assume the value and it countably many infinite times over r plus. So that's the another way of looking the solution of that thing. So the correct option is C. C is the correct option. I hope you have understood the solution to the problem. If you like the video, then do give us a like, and if you want to receive such amazing content, then do subscribe to our channel. Moreover, you can also share it among your friends if they are preparing for this entrance examination. It might be useful to them. So thank you so much for watching. We'll be moving ahead with some other interesting videos. Thank you so much.